Good afternoon, everyone. Thank you so much for joining us today. My name is Michelle Maloney, and I'm the co-founder and national convener of the Australian Earth Laws Alliance. And we're really pleased that you could join us today for this really important and much valued update about climate change from Professor Brendan Mackey, who I'll introduce in just a moment. Before I do, just wanted to do a little bit of promo for Earth Laws Month and also acknowledge country. Okay, so thank you again, everybody, for joining us. In a moment, we'll introduce Professor Brendan Mackey from the Climate Beacon at Griffith University, and I'm really looking forward to our discussion today. I'd like to acknowledge that I live, work and play on the really beautiful lands of the Kabi Kabi and Jinnaburra traditional custodians here in a rather beautiful part of southeast Queensland. I now live in Narangba, but I want to acknowledge that these beautiful lands have been unceded since the earliest days of colonisation. So want to acknowledge the ongoing connection to country and custodial responsibilities that the Kabi Kabi and Jinnaburra traditional custodians have for these lands. I'd also like to acknowledge that the Australian Earth Laws Alliance, in partnership with our sister organisations Future Dreaming and the New Economy Network Australia, are deeply committed to the ideas connected to decolonising the way we think and feel and work on this beautiful continent. It's become a bit of a Zoom tradition to invite people to say hello from wherever you are. And if you know whose country you're on, it's lovely to share that too. This practice, I think, helps many of us learn a bit more about the different countries and peoples around this continent, as well as find out where you're from. So just a quick plug, we're halfway through, almost finished, Earth Laws Month. The Australian Earth Laws Alliance, or AELA, hosted an Earth Laws Month last year, and we've got a terrific response. And so this year we've hosted another one. What's it all about? Well, AELA's goal in life is to help increase the understanding and practical implementation of Earth-centred governance. We often joke it's about Earth-centred everything, but what we're interested in terms of governance is how people can change the rules that we make to live, work and play together, kind of like the coding of our human societies, so that we can be more Earth-centred, more compassionate and much smarter in how we live, work and play. So Earth Laws Month is actually a bit of a celebration of all the wonderful people that we connect with and work with and all of their amazing ideas. We have folks who are scientists, lawyers, economists, deep ecologists, Indigenous knowledge holders, and many, many more people. So if you're not familiar with Earth Laws Month, please visit our website. The link is there, and I'll pop all the links in a moment. It's a terrific way to catch up on a whole range of issues, including, and this is a perfect segue to the complex, terrifying, important work around climate change and how we're meant to be adapting and what we can do together to make the world a slightly better place than what it's projected to be at the moment. That's also a plug for all the recordings from our Economics for the Earth Week are now up on the AELA and NINA websites. But that's it from me. That's all I wanted to say by way of introduction. And now, Brendan, how are you today?
I'm very well, thank you, Michelle.
Thanks so much for joining us. Brendan and I have known each other for many years, and I'm a deep admirer of his commitment to the work, but also his incredible knowledge across his original areas of work in forest ecology and many connected topics, and now for many years leading the very important work at what was the Griffith Climate Change Adaptation Response Group, and then more recently in the last few years has rebadged around the Climate Beacon, doing terrific work. And Brendan, I know that we've invited you to give an update about the science and the practical aspects of what it means to live in a climate changing world, but if you also want to plug any of your upcoming events or conferences, feel free to do so. And without further ado, over to you, Brendan.
Thanks, Michelle. Well, I'll begin by just let me share my screen, get the technology working for us. Okay, well, let me begin by also acknowledging the traditional custodian owners on the land I meet here at Southport. I'm speaking to you from Griffith University's Gold Coast campus at Southport. That's the Yugambeh language peoples, and pay respect to their elders, past, present, emerging. And I would like to add that I intend to vote yes in the voice referendum. So Michelle has asked me to give a kind of climate change update. I'm going to be largely drawing upon the work of the Intergovernmental Panel on Climate Change Sixth Assessment Report. The final concluding synthesis report from that was just released recently. I was a coordinating lead author in Working Group 2, which looked at impacts, vulnerability and adaptation, and was also a drafting author for the Policy for Decision-Making Summary document. And I also want to explain a little bit about the IPCC process, because the information that these assessment cycles present is intended to be reliable and robust, and can be lent upon in people's advocacy work, and drawn upon to help people improve their understanding of the climate crisis that we are living in. But I want to say something to begin with, just to explain about this index that we call global warming degrees above pre-industrial level, because throughout my presentation and everywhere we turn to where we hear about the climate change problem, we hear this discussion which is focused around this idea of degrees warming above pre-industrial levels. And we know we're at about 1.1 degree above pre-industrial level, and some people say, isn't that nice? I live in Siberia, and I'm very happy that we're going to have 1.1 degree of global warming. Of course, maybe being rather than minus 40 degrees, it'll be minus 38.9 or something. Of course, that's not what that means. It's simply an index. It is an index of, much like a thermometer we use a thermometer to give us an indicator of human health. We can think of global warming degrees above pre-industrial level as a thermometer reading of Earth cells. So on the left-hand side of my PowerPoint, at least how I'm looking at it, we all know that a healthy body temperature is around 36 to 37 degrees. 38 degrees is diagnostic of a fever, and above 40 degrees Celsius is life-threatening. Right? If you go to your GP and your temperature is 40 degrees, she'll be rushing you off to the emergency ward in an ambulance. Well, by analogy, a healthy planetary temperature is actually zero. Right? It's zero above pre-industrial levels. And we're currently at 1.1 degree, which I would put to you as equivalent of a fever, planetary fever, to use that metaphor. And above 1.5 degrees is definitely equivalent of life-threatening. In fact, it is literally life-threatening to many things. So just keep that in mind as we go forward, because a lot of the graphs and slides and tables, etc., that the IPCC produces and that people draw upon make use of this index of Earth's climate health. And again, these are the reports from the IPCC's sixth assessment report. Each cycle takes about 7 years from go to woe. So this is the sixth cycle. So think about that. We've had 42 years of IPCC assessments. And there are 3 working groups. The first one looks at the physical science basis. The second one looks at impacts, adaptation and vulnerability. And the third looks at mitigation of climate change, i.e. mitigating greenhouse gas emissions. Then there are special reports. There was a special report on the ocean and cryosphere, climate change and land, and the implications of global warming of 1.5 degrees. Keep that one in mind in particular, and I'll be coming back to that. And then there was what was called a synthesis report, which was a summation of the main points from all of those reports, which was just most recently released. So there's a vast body of information there, science-based information for everyone to dip into and draw upon and make use of. And I want to say something about about the IPCC assessment protocol for what we call a scientific consensus, which is really dealing with the issue of scientific uncertainty. And a scientific consensus is not like a political consensus or a social consensus or some kind of mediation where two parties or multiple parties come together and everyone walks away with something, or there are some winners or some losers. That's not how scientific consensus work. It's really about getting agreement regarding the evidence, the type of evidence, the amount of evidence, the quality of it, the consistency, and whether the different lines of evidence are in agreement. So a scientific consensus is really about the extent to which the available evidence is all giving us the same message or pointing in the same direction, if you like. And that little diagram on the left there, that little table, you can see a bottom axis here, which is kind of the type of evidence. Try and get my mouse to work. The type of evidence, amount, quality, consistency, and the vertical axis is the agreement. So you can see over here, the top right corner, high agreement, robust evidence. That means there's a lot of evidence from many different sources, and it's all telling us the same thing. Top left-hand corner, you can have high agreement, but there's not much evidence. And this is because not much research has been done, not much, it can be social science, or whatever kind of science it is. On the right-hand side, you can also do this quantitatively, and that's where you've got some statistical analysis or model results, but also expert judgment. And here the terminology changes. You can go from being exceptionally unlikely, likely, to virtually certain. Virtually certain means it's 99 to 100% probability. So every sentence and every part of every sentence in the executive summaries and the summary for policymakers has to have an uncertainty assessment, unless it's a statement of fact, which means there's zero uncertainty, if you like. It's better than virtually certain. I wanted to explain that to you just to make it clear that the conclusions that are reached by the IPCC assessments and the high-level statements which appear in the summary documents and which get a lot of publicity and which people quote are based upon a very rigorous, explicit process that involves, if you like, the professional judgment of thousands of experts. And it's not just someone's feelings, if you like, or opinion. It's an assessment of it's a joint collective assessment of the available evidence. And as I mentioned, I was in working group 2, and all the working groups had 2 documents. There's a full report. That was our full report. It's 3,600 pages long. There were 18 chapters. It involved 270 authors from 67 countries. 34,000 scientific publications were assessed. And there's also an extensive open peer review process on about 3 drafts. And there were 62,500 review comments that were officially lodged and responded to, and they're all in a big spreadsheet you can access on the website, in fact. And then that document is summarised in a high-level synthesis, which is actually co-penned between authors and government representatives to translate the science into policy-relevant key messages, i.e. the document on the left is about 35 pages long. It's a 35-page summary of 3,600 words using language that someone in government or works in an agency of some kind would be expected to be able to understand what it means. So let me bring you some of the highlights. You would have heard about these, some of you maybe in other talks I've given, or you would have heard them in many of the messaging you've heard recently. But, you know, and again, what I'm going to talk about first is not future climate, it's what we've observed that's happened you know, over the last 100 years and increasingly over the last decade and up to the present. But global surface temperatures, and again, this is the crudest. This is our single metric index of Earth's health. Global surface temperature has increased by 1.1 degrees compared to the baseline, which is around 1850, which is when the Industrial Revolution really kicked off, and we really started using fossil fuels as a source of energy, and when industrial manufacturing took off. So it's unequivocal that Earth has warmed, and the impacts from that warming have been observed everywhere, in the atmosphere, in the oceans, in the cryosphere, which is all the ice, and in the biosphere. And this provides, and this is IPCC language, unequivocal evidence of a world that has warmed. So a globally warmed world is now a known scientific fact. There is zero uncertainty. Right? It's more than virtually certain. It's unequivocal. It's an established fact. And we've seen, again, just going through some of those changes. Here are the observed changes in global mean sea level. This is going back thousands of years, and of course, or years, sorry. And again, these are these classic hockey stick graphs, just showing you how different the current change is compared to recent past. This is observed changes in the cryosphere. The top right one is Antarctic ice sheet and Greenland ice sheet, cumulative area or mass changes actually of Antarctic and Greenland ice sheet, actually from the 1990s to 2010. So just looking at the last 25 years, 20, 30 years or so, massive changes in the ice sheet mass in Antarctic and Greenland, and that one at the bottom is in Arctic sea ice thickness. This, of course, continues to receive a lot of coverage, especially the Antarctic changes, but that's been going on for some time, in fact. Now, this is, again, there's a lot of detail here, but, you know, this is one of the major findings revealed by the IPCC System Assessment Report. We've been used to talking about climate change in terms of what we call changing climate trends. It's getting warmer, the sea level is rising, the ice is melting. These are, if you like, in the context of the past, rapid, but in terms of human timelines, relatively slow changes in these major parts of the Earth system, you know, changing climate trends. But these changing climate trends have been observed to be bringing about major changes in climate and weather extreme events. So there's a link between the changing climate trends, increasing global warming, increasing sea level rise, melting ice, changes in rainfall, and an increase in the frequency and or intensity and or duration of extreme climate and weather events, temperature extremes, heavy precipitation days, and how heavy those precipitation days are, worsening of droughts. So every small or relatively small incremental increase in global warming, right? This gets back to my initial slide about the thermometer. A small change in global warming in that index causes statistically significant changes in extremes globally and also for large regions as well. So an increase of 0.1, right, in that Earth index results in significant changes in a region in the intensity and frequency of climatic extremes. So they scale with global warming, but in a non-linear fashion. That just means a small increase in global temperature leads to a large increase in extremes. It's a non-linear relationship. And that's just that map, which I won't take you through. It's in the report. I'd encourage you to look it up. It it just shows you where there's evidence that there's been an increase in extreme events recently. For historic reasons, I don't have time to explain, Australia and New Zealand get their own chapter in Working Group 2. And I just want to take you through some of the findings from that. And again, this is making this point that, you know, in Australia, there's been a clear ongoing climatic trends. There's been, and I've shown you the one here is temperature. You can see those graphs on the left over here. Australia's warmed actually at more than the global average. We're probably up around 1.2. Same for New Zealand. There's a bit of spatial variation there. So I've listed some of the trends there. We've had ongoing warming and sea level rise. We've got less snow. There's more rainfall in the north. There's less winter rainfall in the south. And we're seeing all these extreme events happening. I mean, we've all been experiencing them. We're breaking temperature extremes every year. Marine heat wave extremes are being major floods and the like. We've all experienced these in recent years. And they're connected, right? This is called attribution science. The attribution science is what enables us to attribute the change in these climate trends to change in these weather extremes. We used to say, even just a few years ago, oh, we can't say, you know, to what extent this particular extreme event, this heat wave or this bushfire was the result of or connected to global warming. Well, actually, we can now, and I'll talk a little bit about that in a minute. The other point I want to explain is that's talking about a change in climatic conditions, increasing global trends, climatic trends, and how this is increasing extreme weather events, heat waves, heavy rainfall days, those what we call those extreme climatic conditions are what we call impact drivers. They actually drive the impacts we experience. And IPCC has a process for assessing climate impacts and climate risks, which I've laid out here. So risk is defined as the risk to something of value, here a system, given the climate hazard, the exposure of the system to that hazard, the vulnerability of the system, and prospects for effective adaptation to ameliorate the negative impacts of those or consequences of that hazard. So that's what I've laid out there. So on the left-hand side, our system of interest might be tropical coral reefs or agriculture in South Australia. The climate hazard could be, if we're on the coast, sea level rise, or it could be an increase in dangerous wildfire. Exposure is really often a matter of geography. How exposed is our system or our asset to the hazard, if you like, proximity to the hazard. Obviously, if you have a home that's in a low-lying coastal area, you're exposed to sea level rise related hazards. If you live in a floodplain, you're exposed to fluvial flooding. Vulnerability relates to our sensitivity and ability to respond and adapt to reduce our exposure to these hazards or how badly we'll be affected. So for humans, a lot of our vulnerability to climate hazards and a lot of the exposure is related to socioeconomic factors. A lack of healthcare will make people, and poor housing can make people more vulnerable to heat waves, for example. Often, the cheapest housing is in the most exposed locations, such as on floodplains, such as in Lismore, for example. And adaptation really refers to our capacity to anticipate these impacts and to plan and adapt to try and reduce those impacts. So I'll talk a little bit more about those risks in a minute, but these are just some examples of some of the impacts that have been observed from climate trends and extreme events in Australia. the particular exposures and vulnerabilities that have resulted in major impacts, particularly for our natural systems. So we know that the warmer conditions and the winter droughts have led to hotter temperatures, much drier vegetation, more flammable ecosystems, and more catastrophic wildfires. And these have had very big impacts on our terrestrial and freshwater ecosystems. We've had, as a result of sea level rise and associated storm surges, our first extinction, mammal extinction. The Bramble Cay melomys was an endemic mammal species which became extinct due to loss of habitat associated with sea level rise and storm surge in the Torres Strait. And we've all heard about the coral bleaching. We've had a little bit less publicity about the temperate kelp forests, but again, massive impacts on our ecosystems from marine heat waves, and also major changes in species abundance and distributions. So our natural ecosystems have different kinds of exposures and different kind of natural vulnerabilities to these systems, and also different levels of natural adaptation as well. And of course, for human systems, we know that extreme heat has led to excess deaths, and I'll talk a little bit about that more soon. We've had huge impacts of flooding, major impacts of drought. Our tourist sector has been affected by coral bleaching fires, and this year, poor ski season, it's the end of Australia's ski industry. There's no doubt about that. And we've had major costs associated with the impacts of extreme events. So there's clear documented evidence now of the impacts on natural systems and Australian communities and Australian economy at all levels of human-influenced climate trends and associated extreme events. I want to talk a little bit more about future climate or projected impacts and future risks. Everything I've been talking about today is what's been observed. These are, and this is not modelled. What I've been talking about is not modelled. It's just observations, about documented observations about what's actually happened. But we're very interested in projecting into the future, and to do this, we're highly reliant upon global climate change models, which are actually extraordinary tools. They have to take into account, as I show on the left, kind of pictorially, the Earth system, and actually the interaction of carbon dioxide and water and energy between the atmosphere and the oceans, the atmosphere and the land, and actually between the land and the oceans and the land and the geosphere. And they have to be able to, based upon fundamental physics and atmospheric chemistry, be able to replicate how levels of atmospheric CO2 reflect global warming, and to be able to represent the way the global carbon cycle interacts with the ocean and the land. So these are complex mathematical representations of these components, but they are they have now, and there's actually about 52 of them. There's 52 research programs around the world which develop them in parallel through an integrated program called it's an integrated global climate modelling program, and they are all able to quite accurately replicate current climate and past climate, right? And in fact, one of the main sources of information we have, or lines of evidence we have for knowing how what humans are doing are changing the climate, is that the only way we can replicate current climate with these models is to include human forcing that's from anthropogenic greenhouse gas emissions. If you turn off the greenhouse gas emissions in these models, you cannot replicate current climate. So going forward, and again, you will have seen a lot of these graphs one way or other. These just show projection. Well, they actually show historic from about 1950 to current. So there's 4 looking at global temperature, global land precipitation, September Arctic sea ice and glow mean sea level change on the bottom right. Time is on the bottom, and from 1950 to 2100, and there are different vertical axes, and the colours represent different scenarios, which show what might happen to those 4 global indicators, depending on the world community's success or failure to mitigate greenhouse gas emissions. So the bluey purple scenarios are where we pull out all stops and successfully limit global warming to around 1.5 degrees. And the red ones are where we successively fail to do that. The orange ones are, if you like, as I'll explain later on, the orange one is basically where we're heading now if all current policies were implemented, but I'll talk about that more likely. The red ones and maroon ones if we don't do anything. And note that actually, whilst the graph stops at 2100, global warming wouldn't stop at 2100. Nothing, the Earth system doesn't stop at 2100. But what they show, I think, is that we have, and the right-hand column of the top left-hand graph shows, our relative global warming. So you can see it is still possible to limit global warming to 1.5 degrees, but there's a range of projections depending on our success or failure to mitigate greenhouse gas emissions. Interestingly, and this might be a surprise to some of you, global land precipitation increases. A warmer world's a wetter world overall. And that's because a warmer atmosphere could hold more precipitable moisture. 70% of the Earth's surface is ocean. There's lots of evaporation, more evaporation happening, more precipitable moisture in the atmosphere because the atmosphere is warmer, so you get more rainfall. But more rainfall doesn't mean more rainfall everywhere, as I'll talk about shortly. September Arctic sea ice, you can basically see that where we are, whatever we do, we're going to continue to lose an awful amount of sea ice before that stabilises. And global mean sea level change will continue to happen for well below, even if we limit global warming to 1.5 degrees, global sea ice will continue to melt and sea level will continue to rise actually for hundreds of years. And that's because most of the extra heat from the greenhouse gas emissions that's being kept in the Earth system is going to heat the oceans. Actually, it's about 95% of it. And that works its way through the system over a long period of time. There's a big lag effect in the ocean system. So these are the kind of spatial projections. And I guess the message here is, well, actually everywhere gets hotter. Right? So the thing about heat is that everywhere gets hotter. It's if you're hot now, you're just going to be hotter. But some places get hotter more and faster than others, and that's certainly true in the northern latitudes. And we already know that's happening now. The northern latitudes are probably 4 degrees above pre-industrial levels compared to 1.1 globally. And also the higher you are as well. So the Himalayas are warming faster than the global averages as well, and so are the higher latitudes. But there's nowhere which isn't getting hotter, is the point. Rainfall is much more complicated. Some places get dry, but some actually get wetter. And this is, if you think about the fact that all life depends upon water, including human life, so getting less water can be very life-threatening, but also getting too much water is bad, as we also know. So again, this is just showing changes in annual rainfall, not seasonal rainfall. It's not showing you extreme event rainfall. It's just long-term average rainfall. And you can see, if you look at Australia, southern Australia has got drier. Southwest Australia, southern Australia, which is a winter rainfall zone, has probably got about 17% rainfall than it had pre-1970. Certainly pre-industrial, well, compared to 100 years ago, put it that way. And that trend for southeastern and southern Australia will continue whatever we do. Even if we limit warming to 1.5 degrees, southern and southeast Australia will still get less rainfall in winter. That's very significant because less winter rainfall means at the end of winter, our forests are very, very dry and very combustible. And of course, our springs are getting hotter and we're getting more heat waves. Like this week, there's heat waves happening. And that means more dangerous bushfire weather. But as we go, as we go forward, not everywhere is going to get drier and not everyone's going to get wetter, but a lot of places are going to get a lot wetter and a lot of places are going to get a lot drier. Rainfall is very spatially heterogeneous. So these are kind of colloquially called burning ember diagrams. They are a way of summarising an IPCC risk assessment for different systems. And these were identified as the 9 key major climate risks for Australia and New Zealand. And starting at the top left, it's loss and degradation of coral reefs in Australia, then loss of kelp forests in southeastern and southeast Australia, New Zealand, loss of alpine biodiversity in Australia, going to bottom left, forest ecosystem collapse or transition in southern Australia, then loss of natural and human systems in low-lying coastal areas, disruption, decline in agricultural production in southern and eastern Australia, then top right, increased in heat-related mortality in Australia, cascading impacts on cities and settlements in Australia and New Zealand, and failure of institutions and governance systems to manage climate risks. I want to talk about them a bit. The colours, again, if we look at the top left one, loss and degradation of coral reefs, there's 2 columns. One represents kind of low adaptation, which is where we're at, and the other is kind of a moderate level of adaptation by people. That speaks to what can people do about this. The vertical numbers are again global warming relative to 1850. This is our global Earth thermometer. So if we look at this one, and the colours just represent the level of risk. IPCC recognises 4 levels: undetectable, moderate, high, very high. So you can see with loss and degradation of coral reefs, and I mentioned we're already at 1.1 degree of global warming, we're already at very high risk. We're at the highest level of risk already for our tropical coral reefs. And if you think about what we can do in adaptation, well, actually there's nothing really you can do because the main threat to them is marine heat waves, and marine heat waves scale with global warming. And every increment of global warming, non-linear increases the severity, duration, intensity of marine heat waves in the tropics, right? So what's the future of tropical shallow, we call shallow, these are the coral reefs, hard coral reefs in the tropics in the first few metres. What are their prospects? Grim. What can we do about it? Well, actually nothing. Other than limit global warming to 1.5 degrees, right? If we come down to the middle at the bottom, disruption, decline in agricultural production in southern and eastern Australia, this is actually due to that decline in winter rainfall because it's a winter rainfall zone. Our wheat and canola are winter crops. And you can see that it's yellow, the risk is currently moderate, and actually even under moderate, there's a bit of moderate adaptation. So you're kind of well into, up around 2.5 degrees before you're at a high risk. Well, why is that? Well, that's because it's a human managed system, and there's an awful lot we can do to change the kind of agriculture we do. We could do regenerative agriculture, Michelle. We could change what we grow, how we grow, where we grow it. So what this is pointing to is that our agricultural production systems in southern East Australia will have to change if they are to remain productive. But there's a lot they can do to deal with that. If we go up to the right-hand side, I've got increase in heat-related mortality in Australia. I'm going to talk a bit about that a bit more. Again, there's a lot we can do, at least in terms of humans, to to reduce the risk of heat-related mortality for humans, which is why the yellow extends a bit. Let me say something about these two, because these are new risks that we identified for our region. Cascading impacts on cities and settlements in Australia and New Zealand. And we see it's and again, there's a whole spreadsheet of analyses around these graphs. They're not just kind of made up, if you like. They're not very, they get read pretty quick. And we saw this with two examples. We saw this with the Black Summer bushfires and with the Northern Rivers floods, right? We just saw these cascading impacts from one extreme climate event. One extreme climate event had these cascading impacts across human settlements, across all infrastructure, across transportation, across communication, across health services. And related to that is one on the right hand, failure of institutions and governance systems to manage climate risk. Well, we saw this as well in both those extreme events, right? Just a failure of our governance systems. We've kept that one's yellow for a lot longer because, again, that is something which is within our bailiwick to change and adapt. So just to kind of summarize that. So again, this is similar to the graphs I showed you before. We've got going from 1950 to 2100. These are our different scenarios. Blue being yes, we mitigate greenhouse gas emissions. Red or maroon being, well, we just walk away from trying to do that. And this is the level of global warming, our Earth thermometer. So as I said, we're currently at 1.1 degrees. Now, unfortunately, I'm not sure how much this message has gone out. There is another 0.4 degree of global warming locked in, and therefore we are going to hit 1.5 degrees. It's likely to be reached around 2030. Sometime between 2030 to 2040, but it's looking like it's going to be closer to 2030. We will hit 1.5 degrees of global warming. So that comes from the Working Group 1 report. Not the Working Group 2 report that I was in, but that was one of the key messages from the Working Group 1 report. There's another 0.4 degree of warming locked in. As I said, there's lags in the Earth system, you know. So yes, it looks like it is technically possible to limit global warming to 1.5 degrees, but not to below it. And if you think about that, that means we will see as much climate change and increase in extreme events in the next 10 years as we experienced in the last 20. Why do I say that? Well, in 2002, which was the IPCC's fourth assessment report, we had the level of global warming was 0.6 degrees above pre-industrial levels. So 2002, we had 0.6 degrees of global warming. In 2022, we've got 1.1 degree of global warming, which is an extra 0.5 degrees of global warming in 20 years. And the science is now telling us we're going to get another 0.4 in less than 10 years. So it's about a comparable amount of global warming, but in half the time. So if we turn the clock back, let's imagine the year is 2002. I'm giving this webinar, I'm saying, guys, look, in 20 years' time, we're going to have the largest mega fire we've ever known. It's going to burn about 12 million hectares of forests from Queensland to Victoria, and holiday makers and residents are going to be rescued by the Navy from Malakuta Beach. And Sydney's going to be engulfed in smoke for months and months and months that will, where thousands of people will die and be hospitalised from smoke. You would have laughed and said I was a scaremonger. Actually, someone did. Around that time, I gave a talk to the Australian Catholic Bishops' Council, all 34 of them, and at the end of it, one of the bishops stood up and said I was a scaremonger, and I'll leave it to you to guess who that was. He's now deceased. But that's the facts that we're now looking at. We are going to see as much climate change in the next 20 years in terms of impacts as we've seen in the last 10. And our level of mitigation, ambition and implementation which are two things, right? There's the commitments that governments make or industry makes, and there's our implementation of those commitments. That will determine if global warming is capped around 1.5 degrees or if warming will continue. And as I've said, the climate impacts and risks increase in a non-linear fashion. I do that to turn up the dial. With every increment of every little increment of global warming is a big increase in the impacts and risks. So, and I'll just add that, we've had this experience now of a mega fire, and we've had the experience now of a mega flood. Unfortunately, I think, and again, this is just me speculating. It's just a speculation, but it's based upon what we know. I suspect the next mega event where we're going to have a collective experience on is a mega heatwave event. And this is actually, again, this is observed data. This is the number of days Australia mean temperatures were in warmest 1% of records. So this is the frequency of extreme heat waves going from 1910 to 2022. And you can see that the number of extreme heatwave events is increasing. And again, it's a good example of a non-linear trend, right? As global warming increases, we're getting this non-linear increase. And as many of you may know, that in terms of natural disasters, extreme heat is a larger cause of mortalities compared to all other natural disasters combined, which is what that infographic on the right shows. And this is from the Queensland Government's Long Paddock website, which is where they have information that's produced by so the Queensland Government has with partners UQ and I think CSIRO have a very good, it's called a regional climate change model, but it's called a dynamically downscale regional climate model. If you like, it's a global climate change model bespoke for Queensland. It sees Queensland conditions very accurately. And again, if we fail to mitigate greenhouse gas emissions, where would that leave us by 2090 if we just continued as we are? And this is a projection showing the duration of heat waves, how long they would be in days, and the frequencies. So the brown here is 20 to 30 days. The dark brown is greater than 30 days. And these dots are 73 to 110 days. Imagine 100 days. 100 days a year where it's a heat wave, or a heat wave that's 30 days long. And we're talking 35 to 40 degree plus temperatures. Okay. So that's, when I say a mega heat wave event, that's what the data is pointing to. But as I mentioned, the other thing I wanted to mention here, this is just that same, a bit more detail about this key risk 7, which is about heat wave related mortality and morbidity. It's actually for people and wildlife. So there is a lot we can do for people, because we have particular vulnerable populations, young, old, sick people, those in low quality housing, people served by fragile utilities, power and water, remote locations with extreme heat and inadequate cooling and housing infrastructure. There's a lot we can do about that. And that's what the adaptation options are. We can have urban cooling interventions, green infrastructure, increased albedo, better building standards, better resource primary healthcare, etc. For wildlife, and we need to be doing that. For wildlife, there are huge impacts. For example, all the 3 species of flying foxes, lactating females and babies drop dead out of the roosting trees once temperatures reach a certain threshold. So we've had mass fish kills due to low oxygen levels and high temperatures, etc. So there's huge impacts on wildlife and major impacts on people, but there's a lot we can do about the impacts for people if we're proactive. So again, I just wanted to, and this is kind of the last part of the presentation. How am I going for time, Michelle? I don't have a timer with me, and
I think you're doing fabulously because everyone's listening intently. So please continue.
Okay. So what are the causes and solutions? Well, again, this I'm drawing upon data from the Working Group 1 report and Working Group 3. Again, this is all information you've heard and has been socialized, I think, very well. We know that the fundamental cause of the well, if we go to the top left, this is that graph of global surface temperature is increased. We know why. That's the graph below. It's a concentration of greenhouse gas emissions, carbon dioxide, methane, nitric acid. All of them are the main greenhouse gas emissions. And then the graph below that is showing where those greenhouse gas emissions have come from: non-CO2 emissions, CO2 from land use and forestry, and CO2 from fossil fuels. On the top right-hand side, that's the breakdown of how fossil fuel emissions are contributing. We've got 40% from coal, 32% from oil, 21% from gas, 5% from cement production. Cement production is like processing lithological carbon, not it's a different source of carbon. It produces a lot of emissions. So again, we've got, and we can see that around 2005, coal overtook oil. They'd been jostling for first position, but coal has leapt ahead in recent years, and we've got this steady increase in gas. Let's not forget, gas is a fossil fuel. I feel like asking people to repeat that as a mantra. It is not a transition fuel. It's not a low emitting fuel. It is a fossil fuel. The bottom graph is emissions from land use. It's called land use change. It's deforestation. It's emissions from logging native forests and clearing native forests and converting it to another land use, and from agricultural sources, methane emissions from cows, etc. It's about 10% of global annual anthropogenic emissions. So 90%, about 85. So about 85% of the emissions are from fossil fuel and cement. About 10-15% is from what's called land use change, the land sector, agriculture, forestry, and land use. It's also called AFLU, but just think of it as the land sector. That's currently, if you look at the breakdown of the accumulated since 1850 anthropogenic greenhouse gases in the atmosphere, 34% of them are from the land sector, 34% of them are from deforestation and degradation. But over time, the proportion that has come from fossil fuel has increased. And as that graph shows, the amount that's come from the land sector has basically stayed constant for about 50 years. It's still a lot. It's just that we're getting proportionally, the total amount of fossil fuels going up, the total amount of emissions are going up because of increased fossil fuel use. The amount of emissions from the land sector is still a problem, but it's staying constant. So what's the solution? Well, there is no solution other than the rapid transit of fossil fuel to clean energy sources. There is no other solution. So as it says on the top right, all model pathways that limit warming to 1.5 degrees and those that limit warming to 2 degrees, even if we just want to limit warming to 2 degrees, involve rapid and deep, and in most cases, immediate greenhouse gas emissions in all sectors this century. Global net zero emissions are reached for these pathways in the early 2050s, respectively. Right? So on the right-hand side, if you look at the top left, it says net global greenhouse gas emissions. Again, the bottom axis is time, year 2000 to 2100. That top left one, the vertical axis is gigatons of CO2 equivalent emissions, i.e. it's all the greenhouse gas emissions, the CO2, the methane, the nitric oxide. The black shows where we are. The green and the blue shows how annual global emissions have to decrease in time to limit warming to 1.5, and the green shows how they have to increase to limit warming to 2 degrees. And the red line shows nationally determined contributions, the range of them in 2030, and what's currently being, if they are implemented. So the red line shows, if you kind of take the average of all what governments have said they will do, and they do what they actually do, we would be still up here by 2100, not down here. So the mitigation challenge is big. And the bottom two just break that down in terms of CO2 and in terms of methane. So where are we at? And I don't know what those red lines are on my slide, Michelle. That was a random doodle.
I don't know.
Well, you might have.
I was going to say, I don't know if I've accidentally done them or whether the mouse.
Yeah, I think someone else has, because they weren't on. They're not on my. They weren't on my PowerPoint. So I think someone.
Okay, let's ignore the little yellow red.
Got a random doodler at large. You might have. This report got a little bit of publicity the last week. It was produced by the UN Framework Convention on Climate Change in preparation for the Conference of the Parties, the COP, the annual climate change COP, which happens every year with all the world governments, which is happening in United Arab Emirates in December this year. And it's the technical dialogue of the first global stocktake. So what's that about? Under the Paris Agreement, there was a commitment. The big kind of diplomatic breakthrough of the Paris Agreement was the Kyoto Protocol was due to end. They wanted an agreement that involved all countries. They couldn't work out how to get an agreement where everyone would agree to what their emission reductions would be collectively. So the diplomatic breakthrough was we would let each country determine what they were prepared to do. It'd be like Australia would decide what its naturally determined contribution would be, as would Russia, as would Libya, as would every country of the world, as would Brazil. And then someone said, well, okay, that's all very well, but we've got to add them together and do a global stocktake to see where that lands us. So part of the Paris Agreement is to have a global stocktake process, which starts this year and will conclude in 2025 COP. And in 2025, everyone is meant to have taken stock of how, i.e., when you add all the naturally determined commitments together, are they enough to limit global warming to 1.5 degrees or well below 2 degrees? If not, the Paris Agreement says every country will increase its mitigation ambition and come to the 2025 COP with a strengthened nationally determined agreement. So this is the first part of that global stocktake. It's a synthesis report where they looked at all the nationally determined contributions to date and evaluated, did this analysis like I showed you on the previous graph, and to identify if we have a gap between what governments have said they will do and what's needed to limit warming to well below 2 degrees or 1.15 degrees. So here are some of the key findings from this report. Global emissions are not in line with model global mitigation pathways consistent with the temperature goal of the Paris Agreement. There is a rapidly narrowing window to raise ambition, mitigation ambition, and implement existing commitments in order to limit warming. The next one, much more ambition in action and support is needed in implementing domestic mitigation measures and setting more ambitious targets. NDCs are nationally determined contributions under the Paris Agreement. To realise existing and emerging opportunities across contexts, that means different countries and different sectors. in order to reduce global greenhouse gas emissions by 43% by 2030 and a further 60% by 2035, compared with 2019 levels, and reach net zero CO2 emissions by 2050 globally. And you can see that on the, you could kind of get a sense of that from the previous graph I showed you. And they say urgent action is supported need to ramp up implementation of domestic mitigation measures by realising opportunities across all sectors and systems, and more ambition mitigation targets are needed more rapidly. And finally, achieving net zero CO2 and greenhouse gas emissions requires systems transformations across all sectors and contexts, including scaling up renewable energy while phasing out all unabated fossil fuels, ending deforestation, reducing non-CO2 emissions, and implementing both supply and demand side measures. So this is an interesting addition, Michelle, about supply and demand. That's because that includes, if you read further in the report, about energy efficiency, about the gains that can be made by energy efficiency and retrofitting, et cetera, and good design, and also about consumer consumption when it comes to red meat and the like. So what can we conclude from all of that? Well, the mitigation gap continues to grow. So the mitigation gap is the gap between what governments have said they will do and what their mitigation targets are, how much greenhouse gas emissions they will reduce by what time, and what's needed to limit global warming to between 1.5 to 2 degrees. That's the mitigation gap. It's growing, which means it's getting harder and harder and harder, a bigger and bigger challenge. Well, this means the time left to avoid irreversible impacts, including severe tipping points, is shrinking. And I meant you might remember back in one of my earlier slides, I mentioned one of the IPCC reports in the sixth assessment cycle was the report on 1.5 degrees of global warming. And that's a really important report to read because they identified a whole bunch of changes to the Earth system and impacts that will be irreversible if we exceed 1.5 degrees. And the more we exceed 1.5 degrees, the more likely we cross these thresholds that lead us to irreversible impacts. And a tipping point, in a scientific sense, a system tipping point is where you hit a threshold that gives you a sudden positive feedback. So an example of that is Arctic sea ice. And I'm sure many of you know this kind of scientific fact that ice is highly reflective. So sunlight comes down and so how the atmosphere heats up is actually the sunlight comes down, it heats the ocean or the land, and that heat radiates back up into the atmosphere. But ice reflects most of the incoming sunlight. It doesn't do any heating. It just bounces back into the atmosphere and basically back into space. So having a lot of ice actually helps cool the planet. But with global warming, the ice is melting and it looks like we're heading to a pretty well near ice-free Antarctic. So in winter, there'll be very little, if any, ice at some point soon in the Arctic Circle, which means for much of the year when the Arctic is currently reflecting sunlight and it's doing no warming, it will be absorbing sunlight and heating. It'll be a positive feedback. That's a tipping point. Obviously, if glaciers melt, that's an irreversible impact. You won't get glaciers melt. And once we're over 1.5 degrees, what happens with coral reefs is hard coral reefs in the tropics, if they're killed by coral bleaching, they can regrow. It takes about 10 years. But once you start to have a marine heat wave more than once every 10 years, once you have one every 2 to 3 decades, the coral reef can't regrow. It just flips into being a completely different system. That's another example of an irreversible impact. but also the adaptation gap grows. And the adaptation gap is the gap between the severity of the impacts and risks, right? The higher the risk and severity of the impact and consequences. And the adaptation gap is the limits to how much we can adapt to ameliorate those impacts and risks. So as global warming increases and the risks get greater and the impacts get more consequential, our adaptation options also shrink. And I'll just give one concrete example of an existential risk that is now being anticipated in Tuvalu. So again, there was a little bit of publicity about this, but not as much as it deserves. A week or so ago, the Tuvalu Parliament voted in favour of or endorsed a new constitution. And in that constitution, there's a section on the Tuvalu sovereignty in relation to its territory. And there's a whole article about climate change impacts. And there's an explicit article in their constitution which states that, basically, to paraphrase it, should Tuvalu territory no longer exist due to sea level rise, they will still exist as a sovereign state. So what they've done is recognised that they can adapt to sea level rise up to a certain point, but if it continues to increase, the adaptation gap would have got so big, there's no more adaptation they can do. Well, the adaptation becomes a legal one, Michelle. They've changed the constitution. They've anticipated the limit to a physical adaptation, and they've shifted to a legal adaptation. And as I said, these things are changing in a non-linear fashion. So the impacts. So I've talked about the increase in global warming causes an increase in climate extremes, which is non-linear. A little bit of warming leads to a big change in the extremes. There's also a non-linear link between the climate impact drivers, these increasing heat waves, and their impacts on human and natural systems. They're also non-linear. So if you can imagine three cogs, you've got a small cog, which is the increase in the Earth's thermometer, a larger cog, which is an increase in the extreme events, and then a bigger cog, which is the impact and consequences of those events. And I'll just leave you with this diagram. This is a diagram from the IPCC synthesis report, which is a final report which just came out. And I think it's quite a compelling diagram. It's just trying to illustrate this point for me of intergenerational justice, that what we do or fail to do today is, in addition to affecting our human family and the greater living of life, greater community of life with whom we share Earth as home today, it's also leaving this terrible legacy for future generations. And this diagram just shows you kind of a coloured index of global warming from 1900 up to 2100, and global warming above pre-industrial levels. That's the colour. And this is someone born in the 50s who's approaching their 70s, has experienced this amount of change. But someone born in the year 2020, this is their life in the red to the right-hand side. So this is now the world that the generation born in 2020 is going to live in. So whether I guess the one of the points of this diagram is we can't make the future, we can't turn the future, we can't turn the Earth thermometer backwards. The future can never be green or brown. It's only going to be red. But there's a huge difference between the very low risk and the very high risk. Right? There's a huge difference between 1.5 degrees and 4 degrees. And that difference is all the difference in the world. And that's the difference we can make. Thank you.
Thank you, Brendan. Wow. As always, the way you present this information, even non-scientists like me can get a handle on it. And I really am very grateful to you for that, Brendan. We have a whole range of questions that have come through, which is wonderful. Folks, I realized that we've advertised this until 1:30, but I and Brendan, the original invitation to Brendan was until 2 o'clock. So we'll try and get through everything we can by 1:30, but if we go over 10 or 15 minutes, we'll keep the recording going. And if people have to leave, then we understand. Brendan, I've tried to group some of these questions together, and I'll just give you a bit of an overview. So we've got questions about taking action now, and I might go to them first. So we've got a really action-oriented feel after all of that profoundly depressing information. There's also some technical questions, which we can go into. And then questions about regional adaptation, seeking clarification on some of the issues facing Australia. And then some more general ones about fossil fuels, renewables, etc. And then some interesting ones about institutional structures and so on. So firstly, I'm just going to put the questions closer to where I can see them. Okay, so are you ready, Brendan?
Yeah.
Great question. Someone has asked, what's the best return on the efforts that we should be doing right now, the things that are in our sphere of influence in Australia? For example, is it addressing fossil fuel extraction for use here and exports, expanding renewables, or other things?
Well, that's a good question. I guess all of the above is the short answer. I think though, there's actually there's another webinar I'd like to give at some point, Michelle. Each year we do this is our second. We've done we call a National Climate Action Survey. It's a bit more comprehensive than the other surveys people are doing. It's designed by a social psychologist. It's quite a large sample, about 4,500. That's represented the Australian population, and we're just about to release this year's report. But one of the I am answering that question.
No, please.
One of the interesting results is one of the results confirms what everyone says is about 78% of Australians are completely convinced about climate change. There's only 2 or 8% who are kind of deniers or skeptical. But interestingly, of that 78% who kind of fully accept climate change, only 15% think that climate change is like a crisis and an urgent problem we need to prioritise now. They don't. It's not a priority for them. 15%, and so the other whatever that was, percent of that 74% think it's a problem, but it's not the priority. It's not. Government should be prioritising above everything else. And to me, this explains some of where the major parties have pitched their climate policies, including Labor. The 78% of Australians of all political persuasions who want climate action, but there's only 15% who want climate action now, right? Who see that we've got a climate crisis. So I think I think engaging in the political process and writing to your elected representatives and the ministers and letting them know that you think it is a climate crisis I think it does make a difference. And having those conversations with families and friends and workplaces and pointing them to reliable sources of information that it is a crisis. It's not just people aren't making it up that it's a crisis. The science is telling us it's a crisis. I think that's an action everyone can take. Clearly, the priorities is transiting off fossil fuel and onto clean energy sources, and that's a huge problem, isn't it? We've got this embedded pathway dependency, sunk capital in the fossil fuel sector, all these vested powerful interests. We've got how the state and federal governments are all dependent upon royalties and fossil fuel taxes. But we know that's all kind of economic nonsense, because we know, there's $60 billion worth of public subsidies on fossil fuel and all of this. So, I think, and again, anyone who's an economist needs to be mounting the economic case for the transition. I mean, I know people are, actually John Hewson's been writing well about this. Garneau writes about it. There's a lot of information out there. I think we're I'm just pointing to the fact that there's a strong economic case for it, as well as climate case. I think dealing with transiting off fossil fuel is clearly an issue. Yes, we need to stop fossil fuel exports, and yes, we need to be making the change domestically. We need to do both those things in parallel. I mean, our fossil fuel exports do more harm than our domestic fossil fuel use, in a global context. So.
And a big question linked to that, Brendan. Thank you very much. And I'll circle back to the questions about taking action and also trusted resources. It's a big issue. But just while we're talking about obviously the need to phase out of fossil fuels as soon as possible, JP and others have raised a really important issue, which is shifting to renewables is a great idea. I'm paraphrasing, of course, but if we continue to do what we're doing now in terms of energy consumption, energy demand, and population growth demanding energy, a lot of the construction of the renewable energy mechanisms to technologies will continue to eat up the kinds of energy consumption we have today. So can you talk a little bit about what you see as a future for shifting to renewables without sort of green extractivism becoming the new problem?
Yeah, and I think, to take a step back, the climate crisis is a manifestation of the fundamental lack of sustainability in how humans are living on this planet. So it's easy to imagine, imagine we have a technology that gives us a limitless supply of clean energy for free. I mean, nothing could destroy the planet faster if that's in the context of a growth economy, which treats all environmental impacts and the land as externalities that we can ignore from our economic calculations. So, I think, we have to deal with the fundamental flaws in our economic system. But the bottom line is that if we want to have any kind of economy, we really need to limit global warming to well below 2 degrees. The insurance industry is now saying a 2-degree world is not an insurable world. Well, that's our whole economy is based upon insurance. We have judges who are saying 2 degrees is the end of the rule of law because government will just have to impose authoritarian rule, and there goes the rule of law. So the fundamental injustice and the fundamental lack of sustainability will not be limiting global warming to well below 2 degrees. So yeah, it's but that has to be part of the larger discussion.
Yeah, thanks, Brendan. And certainly groups like the New Economy Network, AELA, many others, all the other climate change groups, hopefully are focusing on the demand management issue and reducing consumption. It's just one of those complex issues that often people don't like to think about the overall cumulative consumption of our current societies. But look, we'll come back to those issues. Just talking about trusted references and sources of information, I've had a couple of private questions. One I love, I'm reading it. I don't actually trust government funded information anymore. They don't seem to be telling us the truth. There's other comments. Brendan, is there a place where your group or other groups have got a list of really great information sources, whether it's, and I'll rattle them off, like the Queensland government, you just showed us some scenarios they're doing. Can we trust that? The CSIRO, can we trust that? Are there other NGO groups who are showing scenarios, showing action? Do you guys have like a list of things you would recommend people read to understand and trust that information?
Yeah, well, first of all, the IPCC reports, and I as I mentioned, there were, for each of the 3 working groups, there are actually 2 reports. There's what's called the full report, which in working group 2 case was 3,600 pages long. Working group 1 was 2,000 pages long, and working group 3 was similar size. Governments don't touch them, right? They are all done by the scientists and experts who get nominated and selected to do this through a very complex process. The summary report is called Summary for Policymakers. I was involved in that process of working group 2. It's an interesting one. The idea of that is that you take the key messages and translate that into more plain language that's policy relevant. And that text is actually negotiated with government representatives. Now a subset of the full report authors draft that and then negotiate the text. So those documents are interesting because everything that's in them has to be fully consistent and reflect what's in the full report, right? And the main pushback from governments is, well, you've made this statement, but where's the evidence for it? And then you've got to show the trail of evidence and all the assessments that were done in the full report. So the worst that happens in that process is that some of the messages in the full report don't make it into the summary for policymakers, but they're still in the full report. So one of them is, we've actually got 0.4 degrees locked in, which is as much climate change as we've seen in the last 20 years. That's not actually in the summary for policymakers, but it's in the full report. So what I'm saying is the full reports can be relied upon. They are based upon, peer-reviewed scientific publications. They're limited because if the research hasn't been done, it can't be assessed. So that's the main limitation of it. Coming to Australia, anything Bureau of Meteorology does can be trusted in terms of the science. In fact, they're about to roll out some new, what they call climate information services to do with climate attribution science that I mentioned before, which is going to be really interesting, a bit of a game changer in terms of changing the conversation about the relationship between climate change and extreme events. And so and in terms of CSIRO, again, all their climate science work is very solid. CSIRO is a big organisation. There are big chunks of CSIRO which do a lot of paid, kind of contracted consulting science work. I won't say anything about them, but the climate science stuff is very solid. They work with Bureau of Meteorology very closely. Same with Queensland, DES, Department of Environment Science, their science team who are based at the Eco Science Centre. They've got one of the best climate models in the country, working there. So again, there and they got one of the best climate models in Australia. So I would there are the integrity of our science is still pretty good, I think. At the worst, you'll just get some messages hidden or not highlighted, but they'll be somewhere there in the system. There is I don't know if you know the climate I mean, what I can do is send you a bit of a list to send around. There is some international NGOs who do good work. Climate Analytics is one I can mention, and World Resources Institute. Both of them do a lot of work.
That'd be great, Brendan. We're not even sort of, our core mission is the broader elements of all the things we have to do to support life on Earth, not just climate change, but we still get lots of these questions, people wanting to trust the info and find info they can understand. And actually, someone's just made a really important comment. She says, I'm a believer. I understand what's going to happen, but she doesn't feel that many people can truly visualize or imagine what our future will be like, and that is obviously a limitation for getting people to take it seriously. And I think that's a really interesting issue for communicators and people out there who make movies and stuff. How do we tell people about how this is serious without terrifying people? And I think this is where a lot of the positive responses and the love of place that's going to have to happen for us to do the adaptation work. And in fact, that brings me to a really important question that I was going to ask anyway.
Can I just make a comment on that?
Please.
There's a young, I don't know how young he is. Everyone's young to me now. Anyway, there's a young philosopher, British philosopher called Timothy Morton, who's written an interesting book. He's come up with this concept he calls a hyper-object, and he describes the climate change problem as a hyper-object. It's like it's a real thing, but it's so manifestly large in space and time that we can't comprehend it fully or adequately or satisfactorily, and it just becomes a kind of source of tension. And I think that's true. It's just how do we get people to kind of grasp this in a way where they see how serious it is, but in a way that motivates them to take action.
That's right.
Of whatever kind. And I think this is particularly important for youth in particular. That we find a way of empowering people. I think it's a matter of empowering people, and what empowers people.
Thanks, Brendan. And I was going to say, linked to that is some great questions about picking up on your early comments about, how do we do the adaptation for humans? That's tough enough, but at least we can maybe provide some support for vulnerable people. When it comes to wildlife, like even myself, I have several bird baths. I worry for the summer. I worry for the bats. I've joined a bat group. I'm getting things ready for the creatures. What else can we do for wildlife in this country, given what we're about to face with all the future summers?
Well, the most important way we can help wildlife is to protect and restore their natural habitat. Right? So in Queensland, we could stop logging our native forests. That would help. We could stop clearing our woodlands to grow more cows. That would help. We can invest more money in land care and have more payment for ecosystem service schemes for farmers and the like. So I mean, really, it's the regenerative ecology, protecting what we have, and working with nature to do the best. That's the best hope for wildlife, because of evolution, and life. If we give nature a chance, she will continue to adapt and evolve. And then, first peoples in Australia worked this out a long time ago and got very good at it. But wildlife aren't going to persist if they've got no habitat. And if the habitat's full of weeds and ferals, then there needs to be somewhere safe to migrate to. Yes. But this is the other thing to keep in mind: the wildlife plants and animals and insects will increasingly be on the move, right? As the climate changes, they'll need to, and their habitat resources change, and the climate changes, they'll be moving around a lot. So we're going to have to get used to. We're going to have to get used to new things popping up.
They're seeing that already, aren't they, Brendan? With certain fishes that are normally in the north, moving south and popping up in strange places in New South Wales. Fishermen are reporting catching fish they haven't caught for a while in different places. Yeah,
and in the marine environment, there's probably 300 species that have been detected with major range shifts now.
Wow.
Going from tropics to subtropics to temperate. The marine environment really moving fast.
So nationally, Landcare are obviously brilliant and they do terrific work. And again, in the list of info that you provide to us, Brendan, if you know of any NGOs, or often it's down to the really small groups in local communities who are doing what they can to support wildlife, please let us know that too, because more and more of us are doing collective work, going out and doing stuff. But also, if you've got a yard and you've got some trees, people want to know what they can do. And certainly, can I just say, plant as many native flowering things that are local, because I've just moved house from one place where we had tons of natives and we had 6 different kinds of native bees. And now I'm trying to recapture that in my new place, which is lawn, and I'm about to turn it into flowers. So let's get those insects wherever you can too. All right, some more questions for you, Brendan.
Sorry, just on that note, I mean, there is a national landcare network.
Yep.
We can put you in contact with your local landcare group. And someone mentioned Bush Heritage, that's right. And Great Eastern Ranges Initiative, which is kind of working with landcare groups up and down Eastern Australia, and Healthy Land and Water do fantastic work with local communities and local landowners as well.
Yeah, here in Southeast Queensland, for sure. And lots of the small catchment management groups are just in there every week, every month, doing the hard yards. So it's terrific. Brendan, we might just shift for a moment. There's been some technical questions, as in things that a scientist might be able to answer more than others. So Rosemary's asked, how much is change in reflectivity of the Earth's surface, or at least responsible for global warming compared with emissions? And I learned a new word, the albedo. Albedo. Yeah, I thought she had a typo, but it's a thing. Would you like to explain albedo, Brendan, and answer that question?
Yeah, that's just the proportion of the incoming sunlight that's reflected back into space before it does any warming. So ice, it's about 90%, but water, well, there's about 90% reflected and does no warming, but if it's just water, it's the opposite. So every surface has got the color of the surface, it's basically a matter of color, if you like. Color determines the albedo, determines how much sunlight is reflected and does no warming and how much is absorbed and heats. And so if you want to keep your house cool, paint your cooler, paint your roof white. If you want it warmer, paint your roof black. Put it simply, and green kind of sits in between. So albedo is obviously there varies everywhere you go, because I see Cindy and Walter have got a brown image, you've got a green one behind you, right? They've got different albedo. So it kind of, evens up. But what ice, Antarctic ice, or, is a large amount of ice. And so it has a significant impact on warming if there's ice there or water. But I mean, greenhouse gas emissions, the most abundant greenhouse gas by concentration is actually water vapor. But water vapor is constant. I mean, 70% of the Earth's surface is water, so there's always water evaporating and precipitating out. But greenhouse gas is the greenhouse gases, and in particular CO2, is just a very potent at trapping. Because what happens is the sunlight comes down, it heats the ocean or the land, and that heat is then some of that radiates back up into the atmosphere. And if there were no greenhouse gases in the atmosphere, it would just go back up into space. Right. So Earth would be quite cool if there was no greenhouse gases. Some greenhouse gases is a good thing. But obviously, if you think of a greenhouse gas style, it really determines the planetary temperature. So if you compare the planetary temperature of Venus, Earth, and Mars, Venus has got Earth's average temperatures average surface temperatures around 15 or 16 degrees Celsius, like average annual daily temperature. Mars is about, what's Mars? Plus 400 or something.
Oh.
It's got like 95% CO2, right? So Venus is hotter, not because it's closer to the sun, but just because it's just kind of totally chock-a-block full of CO2. So yeah, it's quite remarkable how sensitive our the global temperature is a function of incoming sunlight, how much of that there is, albedo, and the concentration of greenhouse gases in the atmosphere. I mean, that's the calculation. If you change any of them, you'll change the Earth's temperature, but we're just turning up the greenhouse gas dial really, really quickly. And it's all connected, so because of all the feedbacks we talked about.
Thanks, Brendan. Here's a question well, I'll just read it. The question is, a silly question perhaps, but has anyone measured if the sun's temperature is increasing? Is it a possibility? Someone else said there's debate over the effect of the so-called Milankovitch cycles, but I don't know to what extent they affect us. Brendan should know more. Brendan.
Okay, so yeah, so the Milankovitch cycles is this Russian astronomer, physicist who worked out how Earth's orbit around the sun. It's not simple, because Earth's at a tilted angle, the orbit's elliptical, and there are deviations in it which occur cyclically on different kind of timescales. So, to cut a long story short, about every 100,000 years or so, Earth gets a little bit closer and is at a certain angle where it gets more sunlight, so it heats up. And then there's another part of that orbital cycle around the sun where it gets a little bit further away and it's at an angle and a wobble where it gets less, and you get an ice age. So That's what the Milankovitch cycle does. Yes, so the amount of incoming sunlight at the top of the atmosphere is, that's the major source of energy for Earth. There is another source, which is the core, because it's molten core, and so there is another source of energy, heat energy, which is coming from the core, which is one of the reasons why life first evolved, we think, on the bottom of the ocean floor, where all of that, it was created by that, but that's a story for another day. So that's why, if you go back 20,000 years or so, in the ice core records from Antarctica show this sawtooth effect of every 100,000 years going in and out of a glacial cycle until about 10,000 years ago. Until about 10,000 years ago, we stopped. So you go back 1 million years and the seesaw effect every 100,000 years, we were into a glacier, out of a glacier. It was kind of capped, but seesawing between a hot and a cold, a warmer and a colder thing, till about 10,000 years ago, and when the global temperature just leveled off. Now, until about 100 years ago, when it started doing that. So we had these natural processes that kind of had this seesawing effect, and then the global temperature went flat, and now with use of fossil fuel, it's doing this. So why did it go flat? Well, there's a couple of theories for that. One is that humans caused it to go flat because that's when we discovered fire and started burning and clearing vegetation. Right, so we actually produced the invention of fire and the spread of the human population around the planet actually created, strengthened the greenhouse effect, which stopped us going into an ice age. Some would argue that was a good thing because the climate stabilized and we could develop agriculture, and some people think it's a bad idea. But anyway, that's modern civilization is based upon the fact that 10,000 years ago, we got the stable climate. There's a growing scientific view that we created that by turning up the greenhouse dial after we discovered we could manipulate fire and use it to manage land. And now we're burning fossil fuel, and we're doing this. So the solar input changes as Earth moves around the sun, and also with solar flares and things. But the greenhouse effect is just so strong. It's like just the major, it just overrides the other factors, if you like. They're in there in the formula, in the energy calculation, temperature calculations, but it's the greenhouse factor which is the strongest one.
Thank you very much, Brendan. A few people have been appalled that we have to have Brendan explaining basic science concepts, but perhaps with a compassionate approach, we can remember that if people were lucky enough to be taught this in high school and they're now much, much older, a lot of this information is forgotten, or a lot of this information was never known. So it's always good as grown-ups to be reminded of how things work. And honestly, it would be the key argument of the Australian Earth Laws Alliance that most of us do not know enough about how our local ecosystems or our beautiful planet actually works to pay it the due respect to adjust how we live on this place. So I think this is actually at the heart of the issue. So thank you, Brendan, for that wonderful explanation. There's another, what I would call technical, as in what causes what. Someone's had a question about what impact does the Russian war have on climate change? Does a bomb heat the atmosphere? Is the reduction of normal economic life reducing local climate change impacts? It's an interesting question. Brendan, any thoughts?
So what's the question?
I think the question is what impact do wars have on climate change?
Oh, well, I mean, war is interesting. Modern war, of course, needs fossil fuel. I mean, there aren't electric tanks, right? There aren't electric fighter jets. So I think, the machinery of war, as we see in the terrible war going on in the Ukraine, is it's a fossil fuel war. And a lot of it's about fossil fuel because eastern Ukraine and southern Ukraine has a lot of fossil fuel. So however you look at it, fossil fuels implicated. Obviously, the use of the machinery of war increases emissions. I've read that Russia is paying for its war by selling its oil and gas to whoever. So, I can't see while Putin is president of Russia and is fighting a war in the Ukraine that he's going to care about his nationally determined contributions under the Paris Agreement. So, I think we'd have to say that war is, from multiple perspectives, making the climate crisis worse.
Thanks, Brendan. I was invited recently to speak about the environmental impacts of war and militarism and dug up some basic stats. And the entire planet, or human beings, if you put all of our money that's been invested into the military, then the military efforts across all aspects, I think it's something like the 4th or 5th highest emitters of carbon in terms of just the sheer scale of the machines, the buildings, the people, the staff, the training activities, and so on. So yeah, war, not good for much. And with our remaining time, actually, there's a great question about institutional stuff. And then with the remaining time, we might just turn finally to, again, back to our regional impacts and regional knowledge. Cindy has asked an interesting question. She says, I've just learnt about the Climate Overshoot Commission. Any likelihood that Australia will be included? I must confess, I have never heard of this. Do you know, Brendan, about it?
No, I've not. I think I had some publicity on it recently. There are some people proposing that, if we can't transit to clean energy sources and if we can't remove the carbon, we're going to have to start doing planetary scale geoengineering by putting metal in the sky that will reflect the sun. Okay. I mean, yes, if we want to kill Earth completely, let's do that. Like I'm trying to think of a polite way to say what a stupid, bad idea this is. I won't. I mean, it's like giving someone a gun and putting it to their head and saying, "Here, pull the trigger." I mean, I can't think of. I can't. We have a climate crisis because we're geoengineering the Earth system. It's precisely what we're doing now. So saying we can fix the climate crisis by another geoengineering planetary scale intervention is, it's just nonsense.
Okay.
I'm really struggling to see who and what's behind it and why they would be promoting it, other than someone can think they can make an awful lot of money from it. I can't see why anyone would think it's a good idea.
Thanks, Brendan. I won't comment on geoengineering either. I'll just bite.
Because we are geoengineering. It's precisely what we're doing.
Yeah.
Right? Burning fossil fuel and putting in the atmosphere and deforesting the planet is planetary geoengineering.
Which brings me to our next regional question. Everyone asked, or many questions about how urgent is it for Australia to end native forest logging? That's a very easy answer, I think, isn't it, Brendan?
Yeah, it is because, wood is good, but let's look at where we get our wood from. Currently, we get 85% of our wood from the plantation estate. And there's about 134 million hectares of forest and woodland in Australia, 2 million hectares of which are plantations. And that 2 million hectares of plantations is supplying 85% of our wood. Right? And that's because all wood-based products are now manufactured wood products. So what we're talking about is providing a woody biomass that feeds into a manufacturing wood sector. Most of the jobs, about 85% of the jobs, or 75% of the jobs, are actually in manufacturing as well. So the actual problem we've got is a lack of investment in the manufactured wood sector, right? Because we export whole logs actually from our plantation estate. So, and it's easy to imagine a slight increase in the $2 million plantation estate to supply 100% of our wood, rather than just 85%. So there's no need to log native forest. And the other thing is, in Queensland, the forestry sector argues that we can't grow hardwood plantations here, and we need hardwoods for certain veneers and things. Well, guess what? There's now new technology which enables you to make manufactured wood, to basically make manufactured wood products from softwood plantations, has the same building qualities as the hardwood plantation timber. So that argument's no longer valid. So the only reason we do it is just kind of a historical legacy thing. Same, there's sunk capital and people and communities and people who have worked in this area for a long time.
Yeah.
Against that, we have all the ecosystem service benefits from not logging native forests, which includes increased carbon sequestration and retention, right, for a longer period of time, habitat for threatened species such as greater glider, cleaner water, and a bunch of other stuff. So, yes, I just from a climate change point of view, we know that logging creates nationally, native forest is at least 30 million tonnes of CO2 a year. And we know that log forests store 30 to 70% less carbon than a natural forest, old growth forest, depending on how intensive it's logged. So it's very good. And we also know that older forests are more climate resilient and more fire resistant than logged forests. So there's many climate reasons to not log native forests.
Absolutely. Thank you, Brendan. And in fact, that brings us to the final question about the regional, particularly regional stuff. But Tom has asked, I think this was back when you were showing the projected changes in Australia. He says, bushfires don't seem to be in the top projected change in Australia's risks. Is that because the risk is already very high?
Well, that's a good question. The risks were not hazard-based, they were system-based. So, yeah, that's an important thing. Some people analyse climate risks in terms of the hazard, right? The focus of the risk assessment is the hazard, a bushfire or a flood or a heat wave. What the IPCC did in the last assessment was look at systems, human systems or natural systems or socio-ecological systems, and say what climate-related risks are they at risk from? So it's multiple ones. So our cascading impacts one, if you read the chapter, the first, we've got a whole box about cascading bushfire impacts and risks. So it's there, but it's in the context of the system we're looking at. So we've taken a systems approach to the risk assessment rather than a hazard-focused approach. If that makes sense.
Okay, thank you, Brendan. And finally, I'm just going to circle back to this, the importance of finding reliable information in terms of anyone in their local place, whether it's their bioregion or their catchment or whatever, finding out information about the things that people think will happen and change in the next coming decades. Where's the most reliable information that we can find for that? Particularly, we work with lots of community groups who are trying to think about their future and how to understand what to do and what to plant and what to replant, how to change.
Yeah. Well, both the Queensland and New South Wales state governments, their climate information platforms, I think, are good and quite comprehensive and reliable.
Okay.
The Long Paddock one in Queensland is excellent.
What's that called? Sorry.
Long Paddock.
Oh, Long Paddock. Yes.
A lot of useful information there, and the New South Wales government website as well. Their climate, I'm not sure what their one's called, but New South Wales. I mean, they've got very good information, and it's improving all the time. And there's a new federal initiative between CSIRO and Bureau of Meteorology and Geoscience Australia have been funded to provide a whole new kind of climate information services, which will be rolling out, I think, hopefully this year, where there'll be a lot of really useful information as well.
Excellent. We will keep an eye on it all. Well, Brendan, it has been epic. Thank you heaps for your time. Everyone's very grateful. Is there any other stuff you'd like to share with us before we head off? I always like to say, is there anything I should have asked that I forgot to?
Not from me, thank you. Oh, yes, there is. Yes, there is. We're having a National Climate Action Summit in Brisbane in November. And we've actually organised it with 14 national peak organisations, and people are welcome to join. There are discounts for it's being run in the convention centre with these peak organisations, so it's attracting a lot of their members, but it is open to the public. there is discounts for small community-based NGOs and like a 50% and a 20% discount for large, wealthier NGOs. Anyway, if I will send Michelle the website link and maybe you could distribute that.
I've just popped it in there too, Brendan, but we'll put it in when we send folks the recording.
Okay.
And someone's asked, shouldn't we be online and not flying? Yes, there is an online option. And how many days is it, Brendan?
Well, you can attend virtually. There's one day of like plenary and panel discussions, and a second day is actually, we call it learning labs, where it's actually more kind of practice focused.
Excellent. Wonderful. Well, Brendan Mackey, you're awesome. Thank you for your time. Really appreciate it. And I will be back in touch with you to have some more webinars about some of these other issues that you've flagged. So we're very grateful to you. Lots of lovely comments. Everyone saying thank you. Lots of clapping going on. It's a bit difficult, isn't it, in a virtual environment? You don't hear the applause, the love, but there's applause and love coming online.
Thank you. Thanks, everyone.
Thank you, Brendan. And thank you to everybody for joining us. Don't forget, we have more webinars tomorrow. There's a really cool one about women's environmental leadership in Australia. And I really hope you can join us. Visit the website, earthlaws.org.au, and you'll be able to find the link, earthlaws.org.au. Or if you've been to our Humanitics tour page, you will find it. Thank you so much, everybody, and we'll see you soon. Thanks again, Brendan.